August 1977, an Ohio State University radio telescope recorded a sound no one had heard before, a 72-second burst, faint but unmistakable, at exactly 14.20.436 MHz. That frequency is the hydrogen line, long considered by many researchers to be the most sensible channel for an extraterrestrial hello. When astronomer Jerry Akin noticed the anomaly on the printout, he circled it and scribbled one word in the margin: wow. What did it mean? An intentional signal from intelligent life? An odd astrophysical event? Or simply a comet passing by? Subsequent searches over decades never found it again, and the mystery endures. All we can say with confidence is its origin, towards Sagittarius, a dense region of sky near our galaxy's center. Half a century on, the cosmos drops another puzzle into our lap, an interstellar visitor labeled 3I 2017 U1, now cutting through the solar system. Unlike earlier interstellar arrivals, Oumuamua and Borisov, this object resists easy comparison. Its trajectory traces back towards Sagittarius, the same sky sector tied to the WOW signal. In May 2025, NASA's Transiting Exoplanet Survey satellite, TESS, was doing its routine survey, watching stars for tiny dips caused by orbiting planets. Buried in TESS data from May the 7th through June 2nd, however, was a faint moving point. Follow-up showed it was inside our own solar system, detectable even near 6 astronomical units from the Sun, a distance at which water should be frozen solid. Yet the object was already showing activity. On July 1st, a 20-inch telescope from NASA's Asteroid Terrestrial Impact Last Alert System, ATLAS, flagged something remarkable. Within a day, orbital calculations made it clear. This object was traveling too fast to be gravitationally bound to the Sun. On July 21st, the Hubble Space Telescope imaged it, revealing a teardrop-shaped coma shedding gas more than 400 million miles from the Sun. Early signs even indicated a plume facing the Sun. The transformation accelerated when southern observatories took a closer look. On August 27th, Gemini South on Cerro Pachon in the Chilean Andes produced the most detailed images so far. Using the Gemini multi-object spectrograph, astronomers observed 3I 2017 U1 in ultraviolet, blue, red, and near-infrared light. The images showed a fine antisolar tail extending over 50,000 kilometers, while the Coma, once compact, had expanded to nearly 19,000 kilometers. In a matter of weeks, the object had evolved from a faint dot into a full comet with a streaming tail, the classic sign of a body responding to solar forces. At the same time, NASA's Sphere X mission mapped a vast carbon dioxide cloud around the object, stretching roughly 350,000 kilometers. On August 6th, the James Webb Space Telescope trained its infrared spectrograph on ATLAS and returned surprising chemistry. Carbon dioxide dominated, the CO2 to water ratio measured at about 8.1, among the highest on record. Webb also detected carbon monoxide, OCS, and dust, while water, usually the hallmark of comets, was only a trace. Hubble later tightened constraints. Though the telescope can't see the nucleus directly because it's obscured by the Coma, its measurements let astronomers set size limits. From those constraints, the nucleus appears tiny, no larger than a 2.8 kilometer radius, and possibly as small as 160 microns. That corresponds to a diameter somewhere between 0.32 and 5.6 kilometers, smaller than many solar system comets. Yet Atlas is outgassing with the vigor of a much larger object, like a town-sized snowball, venting gas at the rate of a mountain-sized comet. Spectra from the European Southern Observatory's Very Large Telescope added another puzzle. Nickel gas appears in the Coma, but iron does not. In most comets, nickel and iron appear together, companion elements forged in supernovae, so their separation here is unusual and could hint at chemistry formed in a very different stellar nursery. Is this a sign of a technological origin for 3I Atlas? Perhaps not, but taken together, the observations sketch an oddball comet, small yet hyperactive, water-poor but CO2-rich, bearing an atypical chemical signature and arriving along an orbital plane that aligns suspiciously near the plane of the planets. Indeed, 3I Atlas plunges into the inner system on a steep, retrograde path. Astronomers have marked several milestone dates to watch as this visitor races through our neighborhood. October 3rd, 2025, Mars Flyby. Just after sunrise over Val Marinus, the comet will sweep past the red planet at roughly 18 million miles. From orbit, Maven and Tianwen-1 should catch the dusty Coma, beginning to glow faintly pink in the Martian dawn. October 29th, Perihelion. 4 weeks later, 3I Atlas will skim behind the Sun, approaching to 1.36 astronomical units, about 130 million miles from the photosphere, where its speed will peak near 152,000 km/h. At that stage, the comet will be lost to Earth telescopes, hidden by solar glare. Spacecraft at Mars and the Sun-Earth L1 point will continue observations as jets of vapor erupt from newly warmed terrain. December 19th, 2025, Earth distance check. With its tail fully developed, 3I Atlas will pass about 170 million miles from Earth, too distant for naked eye viewing, but accessible to instruments like James Webb and the Rubin Observatory for isotopic sleuthing of the Coma. March 16th, 2026, Jupiter Pass. The visitor will make a distant swing past Jupiter, about 33 million miles above the planet's cloud tops. If NASA authorizes a late redirect, the Juno spacecraft could be retasked to sample the comet's dust stream, giving us a rare close-up of material formed beyond our Sun. After perihelion, 3I Atlas will head back into interstellar space, never to return, leaving behind terabytes of data and many unanswered questions. What captures the imagination is that its incoming direction overlaps the same general region of sky associated with the famed WOW signal of 1997 in Sagittarius. Some scientists, including Harvard astronomer Avi Loeb, find that coincidence intriguing. As Loeb notes, could 3I Atlas be natural and simply share an origin direction with a region that once produced an enigmatic signal? Yes. Could it be part of something much larger, a moving message, a beacon, or a probe? We can't exclude the possibility. That uncertainty is part of what makes the idea fascinating. Other researchers propose the object could predate our solar system, a wanderer from the Milky Way's thick disk, drifting for billions of years before arriving here. As 3 Atlas approaches perihelion on October 29-30th, 2025, it will pass about 1.36 AU from the Sun, safe for Earth, but close enough for continuous monitoring. As it rounds the Sun, its activity should ramp up. Gases will vent more vigorously, and the tail will elongate under solar wind pressure. For astronomers, this is a rare window. Under thermal stress, a comet reveals its inner nature. As Atlas brightens and flares, it may finally yield clues about its composition, origin, and how it endured such a long, solitary voyage. In fewer than 10 years, 3 interstellar visitors have crossed our skies. Each one has been different, and each offers a piece of the broader picture of worlds beyond our sun. Thanks to modern telescopes, we're watching this latest traveler not as a transient blip on a plot, but as a living comet, a relic of an alien system passing through our skies before vanishing back into the dark. What are your thoughts?